Hello everyone, welcome to today's video. So the video is really interesting. I hope you have watched the previous video that is about the theta, and today we are going to discuss about the topic you can see here, that is complete understanding of trigonometric functions. Okay, so let's start. So first of all, in class 10 you have learned that this is a triangle, that is a right angle triangle, and as you know this is the perpendicular. As you can see here, we can mention it by P, and this is the hypotenuse, we can mention it by H, and this is the base, that is B. So suppose this is the angle theta. Okay, so on this simple geometric figure we have learned the sine theta, that is sine, that is the ratio, we have learned the ratios. Okay, so these angles ratios, that is sine theta, that is equal to perpendicular by the hypotenuse, that is P by H. As you can see here, I have already mentioned all of this. Okay, but it was based on the simple geometric figure. But there is a brother of geometry. What is that? That is the coordinate geometry. As you can see here, I have already write down on the board, that is coordinate geometry. So according to coordinate geometry, we can use this sine, that is as a function. We know that if we write f of x, that is called function of x. Like that, you can say that this is sine x, means function of x, that is sine, that is cos, cosine, cosec, sec, tan and cot. But you have to know that this sine and cos, they are the basic trigonometric function according to the coordinate geometry. Why? Because if you know the sine theta or sine x or cos theta or cos x, these two functions can make this cosec, sec, tan and cot. I hope you know that, because the reverse, the reciprocal of sine x, that is equal to cosec x, and the cos x reciprocal is sec x, and the tan x means sine x by cos x, and cot x means cos x by sine x. So we can say that these four functions are derived form. So we can state that this is the parent part, and they use them to create this kind of childrens, that are the derived part. Okay, so these are the derived function, that is cosec x, sec x, tan x and cot x, and sine x and cos x the basic. Okay, so now let us understand how we can use these functions in the coordinate geometry. Okay, now on the coordinate geometry we already know that this is the first quadrant, that is plus plus, and this is the second quadrant, that is minus plus, this is the third quadrant, that is minus minus, and this is the last, that is fourth quadrant, that is plus minus. Why? Because on the right hand side you can see that the value of x axis always will be positive, and on the left hand side from the origin, according to the origin or with respect to the origin, you can say that the value of x will be on the left hand side will be negative. And if you see the y, so it was always, or it is always on the upward direction, that is positive, on the downward direction, that is negative. So now how we can use this coordinate geometry to find the value of function, that is sine x. Okay, so suppose on the previous class we have learned that is this is a initial line, and after moving it towards the anti-clockwise direction it will be stop here. Suppose this stops here. Okay, so let us draw a line like this. Suppose the line is moving and stops here, so draw a perpendicular on the x axis. Okay, as you can see the line is moving towards anti-clockwise direction. From the previous classes we have learned that theta is always will be positive. Okay, on the anti-clockwise direction theta will be positive, but on the clockwise direction theta will be negative. So as you can see here, this is the base, this is the base, this is the hypotenuse, and this is the perpendicular. So from this, if we use the basic geometric figure, so we can see that sine theta is always equal to P by H. Okay, so the thing is we have to learn, that is we know that base or that is perpendicular or height is always less than the hypotenuse. Why? Because hypotenuse is equal to the root over of base square plus perpendicular square. So as we know that if you have root over 4, we can easily find it. So it is a practical value, that is 2. But if we put here a minus, then it is not possible to find that. Why? Because according to the complex number, we have an assumption that is minus 1 into 4. So if I put this minus 1 behind this 4, beside this 4, so 4 will be rooted and the value will be 2, and it will be remain minus 1 in the under the root. So it will be called as iota. Okay, so it will call as iota. So it is on the complex number system. You will learn when the chapter will come. So that's why we can't state that length of any kind of hypotenuse is not possible for this kind of stuffs, right? So we have to always mention that hypotenuse will always be positive, as it is not possible to be a negative value under the root for hypotenuse. It is always will be positive. Okay, so now let's take the value of this b. So b is on the x-axis on the right side with respect to the origin, so it will be positive, and always p will be positive, so it is the upward direction of the y-axis. Okay, so in this case they all are positive. Okay, but in case of all cases we will see that is hypotenuse always will be positive. Okay, so in this let me change the pen. So in this phenomena we can see that if I use that sine of theta, so what will be the answer? So as we know, sine theta means p by h. So here the value will be p by h. So p by h. But what will be the sign of this sine theta? So as p is positive in this quadrant and h is obviously positive, so a positive number is divided by another positive number, so answer will be all obviously positive. So that's why sine theta will be positive here, positive. Okay, so let's talk about the cos theta. So if we see cos theta, so meaning of cos theta, that is b by h, that is base by height. So if we see base is plus on this first quadrant and p is obviously plus on the first quadrant, so we can say that b by h, so b by h cos theta, that is b by h obviously positive and b is positive, so b by h. So if a positive number is divided by another positive number, the answer will be always positive. So it will also positive on this quadrant, right? So as you can see, this is the parent functions. They can create these all functions like tan theta, cosec theta, sec theta, cot theta. Okay, so if we reciprocal this sine theta, we will get cosec theta. As the value of sine theta is positive, so value of cosec theta obviously will be positive. As the cos theta is positive, so obviously the reciprocal of cos theta, that is sec theta, will also be positive. And we know that in this first quadrant, sine theta and cos theta, they both are positive. So we can say sine theta by cos theta, some positive value by another positive value will be produced any positive value. So tan theta will also be positive in this quadrant. Okay, so as you can see, and the reciprocal of tan theta, that is cot theta, so we can say that cot theta will also be positive. So you can see on the first quadrant, every coordinate trigonometric functions are positive. Let's talk about on this second quadrant. So if we draw a line like this, and the line that is terminal line, that is stops here, and there is a perpendicular, that is P. So suppose it is the P, it is the base, it is the P and H, and I already mentioned that H can't be negative, H always will be positive. Okay, as you can see, the line moving towards anti-clockwise and rotating stops here. So the angle this will be measured at theta, and as it is moving towards leftward direction, so leftward, like anti-clockwise, then it will be always positive angle. Okay, let's see now what will be the value of sine theta here. So sine theta, what will be the value of this function sine theta? That is sine theta, we know that p by h. So the perpendicular is on the upper side, and the upper side of this quadrant is y, that is positive, as you can see here, that is positive. So p divided by h. So as p is positive in this quadrant and h is also positive, so sine theta will also be positive, as you can see, p divided by h, and they both are positive, so the value of sine theta in this quadrant will be positive. Now let's talk about the cos theta. So what will be the value of cos theta in this quadrant? So as you can see, the cos theta is actually nothing but base by height, but you can see the base on the x-axis is on the left side of the origin, and it is the negative side according to the coordinate geometry. So on the left hand side, the value of b obviously will be negative, so negative b divided by, and h always will be positive, so h. So the answer will be, if a negative number divided by another positive number, the answer will be always negative, so the answer will be negative. So we can say that, or we can state that b by h on this particular quadrant minus b by h, so that the value will be negative. And from this we can state that what will be the sign of cosec, that is plus, what will be the sign of sec, that will be minus, and what will be the sign of tan, sin theta by cos theta, positive by negative, that will be also in minus, and cot theta will be also minus. Now see, if the line rotating and stops here, this will be the perpendicular, so it will be p, it will be base, and this is hypotenuse always will be positive, but in this case what will be the value of sine theta? So let's see, that is sine theta, sine of theta, that is sine function. Okay, so sine theta means p by h. As you can see, p is in the downward direction from the origin, that is the negative for both x and y. So we can state that p by h here will be minus p by h. Okay, so minus p by h means it will give the negative value. And also for cos theta, we can see that the perpendicular we already discussed, but in this case the base for the cos theta, base will be always on the left side, so that's why it is the negative part. So minus b by h, as b h is the positive, so minus b by plus h, that answer will be negative. As I have already explained all the things here, so I am targeting to solve this quickly. Okay, so this is the third quadrant where the sine theta will be minus and cos theta also will be minus. But if you see that sine theta by cos theta, that is minus something by minus something, so minus minus will be cancelled out. It means in this quadrant tan theta will be positive, and also cot theta will be positive, the reciprocal of tan theta. So tan theta and cot theta will be positive on the third quadrant. And let's talk about the last quadrant. So today's last concept, that is, suppose the line stops here, and obviously remember that it is moving on the anti-clockwise direction, and theta always will be positive here, and similarly here theta also will be positive like this. So moving like this, so it is theta and it will be positive. Okay, so as this is the perpendicular, this is the base, and this is the height, as we know height always will be positive, so sine theta. So now let's talk about the sine theta on the last but not the least fourth quadrant, that is sine theta. So sine theta will be, the value of p will be on the negative side downward, and h is positive, so minus p by h. So the value will produce in negative. In case of cos theta, it will be, see, on the fourth quadrant the value of b is on the right side of the origin, that is the plus side of x, so that's why it is plus. So plus b by, and h is obviously h, so in this quadrant it will be positive. Okay, so from this we can conclude that in this first quadrant all will be positive. That's why we always say that this is the quadrant for all. And here we can say that only sign will be positive, so we can say this is quadrant for the only sign. And as this only show that the tan theta and cot theta will be positive, so this quadrant only goes for tan, and this last quadrant is only positive for cos. That's why you can say that is quadrant for cos. That's why you can see on your book that the quadrant is divided into all, sin, tan, cos. In the case of first quadrant, if the angle puts here and you can use these functions, the value will be in positive. In case of the second quadrant, if you put sin theta and any kind of degree value that is lying under this second quadrant, then the answer will be positive. In case of cos theta, that will be negative, and so on. So this is all the basic trigonometric functions that related to the coordinate geometry we have learned. And remember, sin theta and cos theta is the basic trigonometric function, but cosec, sec, tan and cot x, they all are derived from. So tell me on the comment how was the class. If you like the class very interesting, please share the video to the students who are willing to learn something new, and please follow me and like the videos. See you on the next class. Till then, bye bye and stay safe.